Okay, friends, today's math 8.3 graphing reciprocals of linear functions. Say what? The reciprocal of a function f of x to the negative 1 is f of x to the negative 1 or 1 over f of x. F of x is basically your y. F of x is y. F of x means like the function of x. So like next year it'll be a lot of f of x equals x squared plus x minus 1 or whatever. Same idea as y equals for our purposes right now. In the first check your understanding, if y equals 4x minus 3, then the reciprocal is 1 equals 1. Sorry, y equals 1 over 4x minus 3. I need to drink water. That means we have a non-permissible x equals 3/4, right? Because we can't have 0 on the bottom. We could solve for x in this situation. If this whole thing equals 0, add 3 to both sides. So now you got 4x equals 3, divide both sides by 4, x equals 3/4. That would make it 0. Now this is what happens here. We draw an asymptote at x equals 3/4. If this is all totally brand new and you have no idea, don't worry, I'm kind of assuming that. It's a vertical dotted line that is never crossed. Now you can use Desmos to play and check and have a look around. I'll just show you something. Where did I put it? So for that first check your understanding, if we graph it out, the red is y equals 4x minus 3. The reciprocal is the blue. And so what happens, I don't know what color I should use here. So this is, red is y equals 4x minus 3. The blue is y equals 1 over 4x minus 3. Now, that asymptote at 3/4, that is where the x-intercept is for our original function. Because that original function, that's where y equals 0. There's different coordinate points all along this line. When it's on the axis here, when x is 3/4, y equals 0. So when we have that now as the denominator, when the denominator is 0, that's an undefined function, which is why the graph does this weird stuff. So you would draw this with a dotted line. An asymptote is a line that isn't crossed. And you'd have to do it very straightly. It's pretty close. This blue will always approach it, but will never meet it. It looks like it does, but it doesn't. This blue here will always approach it, and it will never meet it. If you want, put these into Desmos. Put these into Desmos, and then for this dotted line, x equals 3 over 4. And then you can just scroll down, go way down until you're like in the thousands, negative thousands or positive thousands, whatever, and then zoom in on this reciprocal function and the asymptote, and you will see they do not connect. That's a good little exercise to do so you can see kind of what's what there. Okay, moving along. I was looking at this yesterday thinking this would be tricky over online, but please ask questions. Okay, so we also have a horizontal asymptote because given this, y equals 1 over 4x minus 3, it's impossible for y to equal 0, right? Now, in case that looks weird, like 1 over 4x minus 3. How can you get that to equal 0? You can't, because anything down here that makes it 0 makes it undefined. If we had an x up here, if this was like x over 4x minus 3, and x is 0, the whole thing would be 0, no problem. But we don't have that there, so we have a horizontal asymptote. Notice here, it's right on the x-axis. It approaches, and it looks like it goes over, but it doesn't. It's just because it's the mode that we're looking at. Like I said, if you want to like look in, go real close, zoom in, you can add the horizontal asymptote. That'll be y equals 0. Put these 4 equations in and play around. Have a look. 4 equations on the same page. The horizontal, vertical asymptotes, the asymptotes themselves may cross. Please note that when a function equals positive or negative 1, so will its reciprocal. So what that means is, right here, where they cross, and right here, notice this right here is when x equals 1 and y equals 1. What I meant, the important part is the 1, and so this is negative 1. Where y is 1 and y is negative 1, those are called invariant points. That will help you if you're given one line and then you have to graph the other. These will help you. Because what that means, like when it says when the function equals positive or negative 1, so will its reciprocal. If we look at this right here, whatever it takes for 4x minus 3 to equal 1, just as like 4x minus 3, whenever that equals 1, if it's 1 down here, it's 1 over 1, it's going to equal 1 as well. Does that make sense? Same as if it's negative or positive 1. If we look just a real kind of simple example, y equals x or y equals 1 over x. When x is 1, it's going to be 1 here as well. Sorry, y is going to be 1 here, y is going to be 1 here. If x is negative 1, y is negative 1, and it's going to be negative 1 here as well. So those points are common to like the blue function and the red function. Called invariant points. This was printed out, you know, like when all this started. I didn't change any of the notes. I didn't even look up my Check Your Understandings on YouTube. They're probably there, but I'm going to redo them. Keep it fresh. There's your assignment. Try and go slow through this. If you have questions, ask. Please play around on Desmos, but do not kind of try and get your answers from it. Okay? Can't hear you. So, you know, when you're looking at the textbook, the work text, whatever it calls itself, there's some good information there. If my explanations aren't working super well, have a look at this stuff here. It talks about horizontal asymptote, vertical asymptote. This is on page 653. This is just right in the beginning of 8.3. 8.3. It's the next page. So check your understanding. Number 1, we kind of did that, but I'll do it again. So CYU 1, page 653. So let's get y equals 1 over 4x minus 3. So the way you do this kind of algebraically, determine the equation of the vertical asymptote. So what makes the denominator 0? So you can just set it up like this. Some of you can do it in your head, great. But if you want to see it, 4x minus 3 equals 0. Add 3 to both sides. 4x equals 3. Divide both sides by 4. X equals 3/4. If we plug 3/4 into here, 4 times 3 is 12. Divided by 4 is 3. 3 minus 3 is 0. 1 over 0. 0 is undefined. That is your vertical asymptote. So at x equals 3/4, you draw that dotted line, which we kind of did already. Okay? 2a. All right, sketch a graph. Graph paper. So you don't see what's underneath and be distracted. Okay. And you know, I'm not going to pause while I set this up. If you want to pause it, or sorry, skip it, then do it. But for those of you who just want to see kind of every step, all I'm doing is creating the grid right now. A few things to look for as we do this, not this part. So this is CYU 2, page 654. 654. Okay, now it says sketch the graph of y equals 1 over x minus 3. Y equals 1 over x minus 3. Anytime the textbook says sketch, do it by hand. If it says graph, it's expecting you to do it kind of with a graphing calculator. And those I wouldn't do because you're not going to get those kind of questions on the final exam. All right, so to do this, one of the easier ways to do this is first graph its reciprocal. Y equals 1 over, y equals x minus 3. Start with that. Negative 3 is the y-intercept, 1, 2, 3. So it's going to cross through there, and it's a positive slope, so it's going to run up and to the right. It is positive slope. What was I going to say? Oh, it's just a slope of 1. Okay, up 1 over 1. So you're going to just kind of follow these dots. That's an important point. So you're just going to kind of keep going, blah, blah, blah. So I can connect those dots. That's an important point because that's when y equals 0. When x is 3, the coordinate points here is 3 and 0. When x is 3, y is 0, which means when x is 3, this function becomes undefined. So that is where our vertical asymptote is going to be. Dotted line. It's pretty far spaced out, but you get the idea. Now, here's kind of a trick, if you will. It's positive, which means this reciprocal function, it's going to be over in these quadrants, kind of like this, top right, bottom left. If it was negative, it would be the reverse. Okay, if you want to make a note of that somewhere, something to remember. Also remember invariant points. This will help you to know kind of where it's going. Where it's 1 and 1. I keep saying 1 and 1. I'm sorry. Where y equals 1. Where y equals 1 and where y equals negative 1. This reciprocal function is going to go through those points. Now, for our purposes, I'm okay with just kind of sketching it from here because the points are going to be really awkward. Like if I want to figure out the 1, 2, 3, 4, 5, like where x is 5, 5 minus 3, well, it's not super awkward. 5 minus 3 is 2, so it's a half. So that would be here, right? If we went, see, to do a point between this point and here, you'd have to go 1, 2, 3, 3.5. So 3.5, so it's 1 over 0.5, so it's 2. So basically, smooth curve, black marker, kind of like that. Notice this one approaches the asymptote. This one should be approaching here, but it's not the best. Same idea here. If you want to plot a couple points just for your own peace of mind, do it. But it's that idea. We could check and see when x is 0. Oh no, that's when x is 0, yeah, it's 1/3. Know what I mean? Negative 1/3, 0 minus 3. And so that would be your point there, and so on. This is hard to do without your feedback and hearing what's what. I hope that's making sense the way I'm doing it. Part B, it says, what's the domain and range of this one? What's the domain and range of this one? Domain and range of this is, of this blue one, x can be anything. But in this case, x cannot be, so part B, x cannot equal 3. Otherwise, x is an element of reals. Y cannot equal what? What can y not equal? Y can't equal 0. Y is an element of the reals. Right? There's no way of making this thing equal 0. Like if we put in x is 1,000, So 1,000 minus 3 is 997. 1 over 997 is a pretty tiny number. Still not 0. Okay? Same as if it was negative. Man, this is hard. Hard to do like this. Okay, example, or check understanding number 3. Use the graph. Okay, so I printed this one out because it's small on my book and I wanted something bigger to kind of keep that there. Be able to work with. Okay, so this is the graph. I'm pretty sure it is anyway. So this is CYU number 3. And it says use the graph of y equals 1 over f of x. So this purple is y equals 1 over f of x. To graph the linear function y equals f of x. And so it's like, what, how do I even begin kind of a thing? This is actually way easier than you think. So if the purple, we'll do it in blue. So if this is y equals 1 over f of x, it's not asking you for the equation. Okay, so don't sweat that. That's next year. Y equals f of x. We're going to do that in red. So we need to graph that. How? The trick here is invariant points. Look where y equals 1. Y equals 1 right here, right? Because it's 1 and then 2. Y equals negative 1 right here. All you do is draw a line through there. Question says, use the graph of this to graph the linear function of that. Should say sketch. All you do that's it. That's it. That's all you do. This is the cleaner version on Desmos. See? It goes through 1 and negative 1. I think that's it, my friends. I just wish I could hear you as you watch this and go, wait, what about this? Or, what about that? In case I'm missing something. But I guess that's what email and classroom is for. Stay in touch.